In this video, I will explain the design of ALU. In 4-bit multiplexer, we first use the basic gate to design a multiplexer and convert it into a block diagram. After that, we instantiate the multiplexer to obtain the 4-bit multiplexer. We group the first input pins from each multiplexer into one input pins, W, and label each of the nodes according to the sequence. After that, we repeat the same step in the following input pins S, Y, and Z. For the output from each of the multiplexer, we group them together into one 4-bit output. Now let's look at the 4-bit adder. Firstly, we also design a full adder by using the logic gates and convert it into a block diagram. Then we instantiate the full adder to obtain 4-bit full adder. We group the 4 input pins into A and another 4 input pins into B. For the output from each full adder, we group them into one 4-bit output X. Lastly, we also connect the carry port of the previous full adder to the next full adder, starting from the initial carry input and end with the last bit carry output. In a 4-bit separator, we actually did the same things as the adder, but we add a NOT gate in each of the B input pins to become first complement. In a 4-bit D flip-flop design, we connect the input pins to each of the D flip-flop and group into 4-bit input D. The output from each D flip-flop, we group them in one 4-bit output Q. We also group the 4 clock pins and reset pins into a single input pins. In this design, we add a NOT gate in reset pins so the 4-bit D flip-flop can reset in once. In the final design of ALU, we begin with the 2 multiplexers to select one of the input A and B from the 4 inputs. Then we connect the selectors A and selector B into the adders and the separators. We connect a VCC pins into the C-in port in the separator, so the initial carry will be 1 to change B into second complement. After that, we add some AND gates and all gates in front of the separator and adder, so we can select either the output from the adder or the output from the separator. We add a NOT gate so it will select the output from the separator when ALU OP equal to 0. Lastly, we add the 4-bit D flip-flop before the final output and connect to the clock input and reset input. Now I will run the timing simulations. Then I will set the input value into a random value. And this is the result.